Have you ever wondered what makes your computer tick? You use it every day for work, entertainment, and staying connected. But what's really happening inside that magical box? Welcome back to DivintoTech. Today, we're diving deep into the heart of your computer to demystify its main components. If you're tech curious and want to understand the foundational pieces of your digital life, you're in the right place. Most of us just click and expect things to happen, but there's a fascinating interplay of hardware working tirelessly behind the scenes. We're going to break down the roles of the 4 key players that make your computer run seamlessly. Think of them as the ultimate dream team, each with a crucial role. We'll be talking about the CPU, RAM, GPU, and SSD. By the end of this video, you'll have a clear understanding of what each does and how they collaborate to bring your digital world to life. Let's start with the Central Processing Unit, or CPU. If your computer were a body, the CPU would definitely be the brain. It's the primary component that performs most of the processing inside the computer. Think of the CPU as a master chef in a bustling kitchen. It takes all the orders, which are really instructions from your software, and executes them. Whether you're typing a document, browsing the web, or calculating numbers, the CPU is the one doing the heavy lifting, crunching those numbers and following those steps. Data constantly flows into the CPU, gets processed with incredible speed, and then the results are sent out to other parts of your computer. It's a continuous cycle of input, processing, and output, happening millions or even billions of times per second. Next up is RAM, or Random Access Memory. If the CPU is the chef, then RAM is the chef's countertop. It's a temporary workspace where all the ingredients, or data, that the chef needs right now are laid out for quick access. Unlike long-term storage, RAM is all about speed and immediate availability. When you open an application or a file, your computer doesn't pull it directly from long-term storage every time it needs a tiny piece of information. Instead, it loads that essential data into RAM. This allows the CPU to access that data almost instantly, making your applications feel snappy and responsive. The more RAM you have, the more countertop space your computer has, meaning it can juggle more tasks and programs simultaneously without slowing down. Now, let's talk about the Graphics Processing Unit, or GPU, often referred to as the graphics card. While the CPU handles all sorts of general tasks, the GPU is a highly specialized artist, dedicated solely to handling all things visual. From displaying your desktop and web pages to rendering intricate graphics in video games or complex 3D models, the GPU takes on this massive visual workload. It's designed to process many pieces of visual data simultaneously, which is why it excels at tasks that demand high graphical performance. Imagine trying to draw a detailed landscape with a general-purpose pencil, CPU, versus having a specialized team of artists with every brush and color imaginable, GPU. The GPU can handle the sheer volume and complexity of pixels much more efficiently than a CPU ever could, ensuring smooth and fluid visuals. Finally, we have the SSD, or solid-state drive. This is your computer's long-term memory, like a modern, super-fast library, where all your files, programs, and the operating system itself are permanently stored. Unlike older spinning hard drives, SSDs use flash memory, similar to what's in your smartphone or USB stick. This means no moving parts, making them incredibly fast, durable, and silent. When you click to open a program or a large file, the SSD quickly finds that data in its digital library and sends it over to the RAM, where the CPU can then access it almost instantly. This speed is a huge reason why modern computers feel so much faster when booting up or loading applications. So how do these 4 crucial components work in harmony? Let's visualize it with a common scenario: opening a video editing software. When you click the icon, the SSD quickly retrieves the program's core files and sends them to the RAM. The CPU then begins executing the program's instructions from RAM, directing the flow of information. As the video editing software's interface appears, the GPU takes over, rendering all the graphical elements on your screen, ensuring it looks smooth and responsive. And as you edit, the CPU, RAM, and GPU constantly work together, pulling new data, processing your commands, and displaying the results, while the SSD stands ready to save your project. And there you have it, the core components that power your digital life. It's a sophisticated dance of processing, memory, graphics, and storage, all working together to bring your computer to life. Understanding these fundamental roles gives you a much better appreciation for the incredible technology you interact with every day. The CPU is the brain, RAM is the temporary workspace, the GPU is the visual artist, and the SSD is the superfast library. If you enjoyed this breakdown and want more simple explanations of complex tech, don't forget to hit that subscribe button and the notification bell so you don't miss our next video. Thanks for watching, and we'll see you in the next one.